These are the practice problems for lesson 2, keeping the equation balanced. And we've been using these hanger diagrams, these balanced hanger diagrams, to visualize what happens with equations. So this has an amount, a weight on one side and an equal weight on the other side. And so as we go through these, the problem says select all of these that apply that keep this hanger in balance as we add different shapes. First of all, I'm going to make the statement. They should make the statement for you that each of these shapes has to have a different weight. Two different shapes cannot have the same weight. So I'm just going to make that statement as we start. Different shapes have different weights. In the first case, it says adding 2 circles on the left side. So add 2 circles on the left side and a square on the right side. Well, up here you have a square on the left side, and that's equal to 2 circles on the right side because these triangles are equal, so you can remove those and the hanger will remain balanced. So 1 square is equal to 2 circles. So if we add those 2 circles on the left side, it's still going to be balanced as long as we add 1 square on the right side. So A works. Add 2 triangles to each side. Well, we're adding the same weight to each side, so B is going to work. C says adding 2 circles on the right side, so 2 circles on the right side and a square on the left side. Well, that's the same as where we started out. Here's 1 square, 2 circles, 2 circles. So this remains balanced as well. And also you can look at it as it's just the square is switching sides and these 2 circles are switching sides. So it remains balanced as you move from one side to the other. As long as you move the same weight in the opposite direction, that hanger is going to remain balanced. It says adding a circle on the left side and a square on the right side. Well, we know that a circle does not equal, 1 circle does not equal 1 square. Actually, 1 circle equals half of a square. So these are 2 different shapes. They have to have 2 different weights. And so D cannot work. And E, adding a triangle on the left and a square on the right. And we said that shapes have different weights. So you cannot add one shape to one side and a different shape to the other side and have the hanger still be balanced. So E does not work as well. So the answers are A, B, and C. This is problem number 2. It is a balanced hanger diagram. So each side has an equal weight. The triangles have a weight of 2.5 pounds each. The circles each weigh 3 pounds. And the blue squares have an unknown weight at this time. So they're going to be marked, labeled with an X. And you're supposed to identify all of the equations that represent this hanger diagram. So here's 5 different equations. Which one represents this situation? Well, the first one says that there are 4 x's on the left side. So there's 4 x's plus 11. So the 2.5 and 2.5 is 5. So the triangles weigh 5. The circles weigh 6 pounds. And 6 plus 5 is equal to 11 pounds. And that's added to the 4x. So that's the left side is okay. The right side is 11.5. So the 3 circles weigh 9 pounds. The triangle weighs 2.5 pounds. Add those together, you get 11.5 pounds. But then there are 2 x's. This only has 1 x here. It should be 2 x's. So A is not an equation that represents this diagram. B says 2x is equal to 5/10. And so a way to approach this problem is to start removing equal weights from each side and see what you can get down to. So I'm going to remove 2 x's from the left side, 2 x's from the right side. Remove 2 circles from the left side, 2 circles from the right side. And so that, a triangle from the left side and a triangle from the right side. So that gets me down to 2 x's plus 2.5 pounds equals a total of 3 pounds on the right side. And so if I want to get to 2x equals 5/10, if I want to check that, I have to get rid of this 2.5 pounds. If I take that 2.5 pounds away, so it's this 3 pounds minus 2.5 pounds. So that is equal to 5/10 or 1/2 of a pound. So these 2x's do in fact equal 1/2 pound, so 5/10. And from this you can see that 1x is equal to 1/4 of a pound, because 1/2 of 5/10, or 1/2 of 1/2 is 1/4, and 1/2 of 2x is 1x, so 1x is equal to 1/4 of a pound. And in this path to get to the 2x is equal to 1/2 of a pound, we went through this drawing. And this was 2x's plus 2 5/10 equals 3 pounds on the right side. So this one is an equation that matches this hanging diagram. And we also started with this diagram. It's 4x's on the left, 2 triangles, so 2 times 2.5, or 2.5 plus 2.5, 2 circles, so 3 plus 3. So this entire left side is represented by all of these figures. On the right side, there are 2x's, 2.5 pounds for the triangle, and then 3 circles, 3 plus 3 plus 3. So the right side is represented by these figures. So these two sides are equal to each other. So E is an equation that represents this diagram. And the last one is C. There's 4x's on the left side, plus 5 pounds from the triangles, plus 6 pounds from the circles. On the right side, you have 2x's, plus 2.5 pounds from the triangle, but 9 pounds from the circles. So it's 3 plus 3 plus 3. This equation only has 6 pounds. So you need another 3 pounds to make this balanced. And let's go back to the beginning here. If you know that now that 1x is equal to 1/4 of a pound, these 2x's equal 1/2 of a pound. So 11.5 pounds plus 1/2 of a pound equals 12 pounds on the right side. And each of these blue squares weigh 1/4 of a pound. There's 4 of them. So 1/4 plus 1/4 plus 1/4 plus 1/4. So that all together equals 1 pound, plus these 11 pounds. So 11 plus 1 pound is 12 pounds on the left side. So the total weight on the left side is 12 pounds. The total weight on the right side is 12 pounds. This is problem number 3. What is the weight of this one blue square if a triangle weighs 4 grams? So this triangle weighs 4 grams, 4 grams, 4 grams, 4 grams. What's the weight of one blue square? And so I'm going to write this using numbers and letters, as well as using the hanger diagram. So this is 2 squares plus 1 triangle, and that is equal to 1 square plus 3 triangles. And so now we can start to remove equal weights from each side to keep it balanced. So I can remove 1 triangle, and if I do that down here with this equation, if I remove this 1 triangle, I can remove 1 triangle from the 3 triangles and end up with 2 triangles. So now we're at 2 squares are equal to 1 square plus 2 triangles. And 1 square is equal to 2 triangles. So now I can remove a square from each side. And so this 1 square now is equal to 2 triangles. And we know that 2 triangles, each triangle is 4 grams. So those 2 triangles together equal 8 grams. So this 1 square is equal to 8 grams. So a triangle equals 4 grams. 2 triangles equal 8 grams. So 1 square equals that 8 grams. And you can get rid of the coefficient. So the square is equal to 8 grams. I'm going to rewrite this one more time using just one variable, the square, and then numbers for the triangles. So 2 squares plus 4 units is equal to 1 square plus 3 times 4 units, or 12. So 2 squares plus 4 units equals 1 square plus 12. And I can subtract the 4 from each side. And so now this 2 squares are equal to 1 square plus 8. 12 minus this 4. 12 minus this 4 right here equals 8. And so 1 square is equal to 8. I can subtract a square from this side and subtract this 1 square right here, and you're left with 8. You can also visualize this as 2 squares are equal to 1 square plus 8. Well, if this square equals this square, you can get rid of them, and you're left with just 1 square is equal to 8, which matches what we got over here. 1 square is equal to 2 triangles. 2 triangles equals 8 grams. So 1 square equals 8 grams. This is problem number 4. So Andre comes up with the following puzzle. And so what we're supposed to do is solve the puzzle. And then Jada writes an equation for the puzzle. And we're supposed to explain the meaning of the variable and each term of the equation. So that word term, that means each of these amounts that are in between the addition symbols. So this is a term, this is a term, this is a term, and this is a term down here. And it says write the equation in fewer terms. So what that means is combine all the x's together and combine all the numbers together. And when we use the phrase write an equation in terms of x, you're going to see up here that there are other letters that we're going to use. There's a letter B for brother and a letter S for sister and a letter M for mom. And then we're going to rewrite everything in terms of x. So things that get added together using only the variable x. So that phrase, write the equation in terms of x, means write everything with the variable x. And finally, solve the puzzle if we haven't done that already. So when I look at these problems, I immediately go to a number line because I will get confused if I don't use a number line. So we're going to call Andre's age x. I am 3 years younger than my brother. And we're going to call the brother B, because down here we're going to turn everything into x's, and that's going to be Andre's age in the end. So Andre's age is going to be x. He's 3 years younger than his brother B. So his brother is 3 years older than Andre. So you move the B out here, separate it by 3 units. So the brother's age minus 3 gets you to Andre's age, or Andre's age plus 3 gets you to the brother's age. The sister is 2 years older. Andre is 2 years older than my sister. So Andre is 2 years older than my sister. So the sister is younger by 2 years. And so place the sister on the number line and then go forward 2 units. That gets you to Andre. Go forward 3 more units. That gets you to the brother. It also says that the brother is 5 years older than the sister. So if Andre is 10, the brother would be 13 and the sister would be 8. If Andre is 20, the brother would be 23 and the sister would be 18. All right, so Andre is x, the brother is x plus 3. So now we're going to start moving this over to terms of x. So this B is going to be written in terms of x. That's Andre's age plus 3 years. The sister, written in terms of x, is Andre's age minus 2 years. And the mom is 3 times, right here, mom's age is 1 less than 3 times the brother's age. So you multiply the brother's age by 3, and then you subtract 1 from that. So multiply the brother's age by 3, and then subtract 1 from that. But how do you get this written in terms of x? Well, notice up here that the brother's age is x plus 3. So we can substitute this b for that x plus 3. So the brother's age is x plus 3. So we can replace this b, or substitute the b for x plus 3. So 3 times the brother's age, and it's 1 less than that. So the mom's age is 1 less than 3 times the brother's age. And all of that adds up to 87. So if we use different variables, x plus b plus s plus m, that adds to 87. But then we rewrite everything in terms of x. That has to also add to 87. And Jada's equation up here matches what we wrote here. Here's Andre's age, the brother's age, x plus 3, the sister's age, x minus 2. We're going to change this to adding a negative 2 in just a moment. And then the mom's age is 1 less than 3 times the brother's age. And remember, the brother's age is x plus 3. So if I write the same thing down here, and I'm using these brackets here to set off the mother's age to make sure that that's separate, and you can see that that's all together equals the mother's age. So that, once again, this is Andre's age, the brother's age, the sister's age, and the mother's age. And so I'm going to rewrite the sister's age as x plus a negative 2. Instead of x minus a positive 2, you can use the inverse operation of addition and the additive inverse of negative 2. I'm going to want to combine everything. It says up here, write the equation in fewer terms. I'm going to want to combine all the x's, and I'm going to want to combine all the numbers. So to make it easier, I'm going to make everything addition. Here we're using the distributive property. So 3 times x plus 3, that means you have 3 x's, and you have 3 times 3, or 9 units. 9, actually that's years, 9 years. And then you're going to add a -1. So I'm going to change this to addition of a -1 instead of subtraction of a +1. Use the inverse operation and the additive inverse. So now I can combine everything together. Everything is just written in terms of x, addition. There aren't any parentheses anymore. These are set in parentheses just to make sure that you understand that that negative for the 2 is not an operation. It is separate from the operation of addition. This -1, that negative symbol, is separate from the operation of addition. All right, so I can collect all the x's together. So there's an x, this x right here, and this 3x, and I can collect all the numbers together. And using the commutative property, I can move everything around, put all the x's together, and put the numbers together. So this is 3 plus -2 plus 9 plus -1. All right, so the -2 plus -1, that together is -3, and 3 plus a -3 is equal to 0. So these numbers disappear. They equal 0. 3 plus -2 plus -1 all equals 0, and you're left with this 9 right here. And what this says is that Andre's age is 9 more, the sum is 9 more than 6 times Andre's age. So if I subtract this 9, it's going to equal 78. So Andre's age is 1/6 of 78. 6 times x equals 78, so 1/6 of that, which is x, equals 1/6 of 78, or 78 divided by 6, which equals 13. So x is equal to 13, that's Andre's age. And from that, you can figure out the rest of the family's ages. So the brother is 3 years older than Andre, so he is 16. The sister is 2 years younger than Andre, so she is 11. And the mom is 47 years old. She is 1 less than 3 times the brother's age. Well, the brother's age is 16. 3 times 16 is 48 years. Minus that 1 year, 1 less than 3 times the brother's age, that makes her 47. So add all 4 of these together. These 3 actually add up to 40, which makes sense. 10, 20, 30, and the 1's digit right here is another 10. So this is 40, plus this 47 is equal to 87. The key to this, in my opinion, is to start with a number line. You will not get confused if you use this number line. This is problem number 5. It says these 2 lines are parallel. Write an equation for each. And because they are parallel, it means that they have the same exact slope. They have the same slant compared to the x-axis. So they go up the same amount, the same angle they form with the x-axis. So here's a slope triangle for this line. And eventually I'm going to slide the same slope triangle over here, and you're going to see that it fits right here. But first of all, let's talk about how to calculate the slope for this line right here. And so the slope is a comparison of the length along the vertical axis, or the vertical length, compared to the length along the horizontal axis, or the horizontal length. In this case, you can just count the lengths of each. So this is 1, 2, 3, 4 units. And along the x-axis, this is 1, 2, 3, 4, 5 units. So that comparison is 4/5. So for every 5 units along the x-axis, this line goes up 4 units along the y-axis. And you can also calculate it. It's the difference of the y-coordinates. So the y-coordinates are 4 and 0. So 4 minus 0 is 4. So that is these 4 units, 1, 2, 3, 4. And the difference of the x-coordinates is 9 minus 4 is 5. So this length is 5 units. So again, the slope is 4 fifths. So for every 5 units, this goes up 4 units. And so now I can take this slope triangle and slide it all the way over here, fit it right there. So this is now a proportional relationship. This line, straight line that goes through 0, 0, or the origin, and has a slope of 4/5. So to write the equations, here's the slope right here, y length compared to the x length. And when it's line A, that's a proportional relationship, that slope is the same as the constant of proportionality. So they are the same thing when you're talking about a proportional relationship. So that slope is 4/5. To use that to write the equations, so for line A, it's fairly straightforward. You just use this form of y equals kx. In other words, the length along the y-axis is the constant of proportionality times the length along the x-axis. So y is k times x. It is k times the length of x. It can be shorter length if it's a fraction, and in this case it is a fraction. So y is 4/5 the length of x. So y equals 4/5 x is the equation for line A. Now line B, it's a little bit harder because there is a proportional part that has to do with the slope of 4/5 x, but also something happened in this situation before you even started. For some reason, whatever happened, they're starting at a negative value, a negative 3 2/10. Maybe there's they owe some money, or something negative has happened before this problem really begins. And so B is actually a negative 3 2/10. So you could write that equation right now. Y is equal to 4/5 x plus a negative 3 2/10. But let's go on a little bit. Let's review how you make those calculations and how to solve this problem in a slightly different way. Using these 2 points, 9, 4, this point right here, 9, 4, and this point right here, 4, 0. Again, to calculate the slope, it's the difference along the y-axis, so that's 4 minus 0, compared to the difference along the x-axis, or the horizontal length. That's 9 minus 4, so 9 minus 4. Don't get confused. These two 4s are different. This 4 right here is the vertical length, and this 4 right here is this horizontal length. Oh, actually, to get to this point right here. All right. So the slope is 4/5. Now to calculate the rest of the equation, you can just replace either of these coordinates with x and y. So I'm going to replace the point 9,4 with x, y. So now to calculate the slope, once again, that is y minus 0, which is y, so y minus 0, compared to x minus 4. So x minus 4. So this is getting the y's and the x's into this equation. So it's the length along the vertical axis, y minus 0, compared to the length along the horizontal axis, x minus 4. Well, y minus 0 is y, and you can see that since this is resting along the horizontal axis, the y coordinate is the same as the y length. Y minus 0 is y. And x minus 4 is you have to remove this length along the x-axis, and you're left with these 5 units. So that's x minus 4. All right, so that's the slope, and so we can set that equal to the known slope, which is 4/5. And so what that's saying is this length y is 4/5 of this length along the x-axis. So it is 4/5 times x plus, and I'm going to rewrite subtracting a positive 4 as adding a negative 4. So I'm going to use the inverse operation and the additive inverse. You can do that. Hopefully you're used to doing that by now. It makes it easier to use this distributive property. You will not get confused. So the next step is to use that distributive property. That's 4/5 x plus a negative 16/5. So 4 times a negative 4 is negative 16, and it's a negative 16/5. Well, a negative 16/5 is the same as a negative 32/10. I'm going to change this negative 16/5 by multiplying it by 1 in the form of 2 over 2. 2 times 16 is 32. 2 times 5 is 10. So I'm just changing the form of this fraction. It's an equivalent fraction, and I'm multiplying by 2 over 2. So now it's a negative 32 tenths. Well, you can rewrite negative 32 tenths. Just say the number. 32 tenths is the same as 3 and 2 tenths. So y equals 4/5 x plus a negative 3 and 2 tenths. That's the same as 32 tenths. So there's the negative 3 and 2 tenths. Here's the negative 3 and 2 tenths. So that proves that they are one and the same. And that number, negative 3 and 2 tenths, is b in the equation. So the equation for b is right here, y equals 4/5 x plus a negative 3 and 2 tenths. And you can rewrite this if you want to as y equals 4/5 x minus 3 and 2 tenths. Those are one and the same things.